properties of solids. Okay, so as you already know, what is meant by solid? So solids are nothing but the particles, those who are tightly packed. The atoms and molecules will be closely packed with a definite order, right? And the intermolecular space between the atoms and molecules will be very, very small. And we can also conclude that solids cannot be compressed, and the intermolecular force in solids is very, very, very strong. And solids will have a definite shape, yes, no, different shape and size. So solids are crystalline and amorphous, that will be learning in chemistry part. And the density of solids is slightly higher than the density of liquid states. That also you know, right? So solids are not perfectly rigid. A rigid body means a hard solid object having a definite shape and size. So but in reality, as you know, solid bodies cannot be stretched or compressed or even bent. So solid bodies are not perfectly rigid. Okay, so that is the conclusion of it. And moving into the topic, we have to learn about elasticity. So elasticity, what is meant by elasticity? You already know that the property which regain its original position, original size and shape when the applied force is removed is known as elasticity. And the deformation caused is also called as elastic deformation. And the main example of that is rubber band, and also you can take an example of steel. So what is the opposite term of elasticity? So the opposite term of elasticity is plasticity. So the plasticity will not regain its original shape or size and gets permanently deformed, okay, which is otherwise called as plastic body. This property we call it as a plasticity. Example, we can say a lot of examples like clay, wax, and even more. Okay, fine. So the next topic is about the deforming force. So the force which changes its length, shape, or volume of a body is called as a deforming force. In simple or other words, we can conclude that the deforming force is nothing but the applied force that is given to an object. Okay, fine. So when an elastic body is subjected to a deforming force, a restoring force is developed in the body. Correct? So this restoring force is equal in magnitude but in opposite in direction in the applied force. Okay. So the deforming force is nothing but the force which is applied or given to the object. Okay. So the next topic is about stress. So what is meant by stress? So stress is nothing but a restoring force per unit area is called as stress. For example, in you can take any kind of objects. So whenever force is developed on body, it changes in area, right? So this we call it as stress. So the restoring force per unit area. Okay, the formula is given by stress is equal to force by area, and the SI unit of stress is Pascal and Newton meter to the power minus 2. And also you can use the dimensional formula for stress as ml minus 1 t minus 2. Okay, so stress is nothing but it is somewhat equal to pressure, but it's not the pressure. It's somewhat equals to pressure, both are same only. Okay, but has a slight variation in it. And moving to the next part, there is three type of stress. Okay, so we can conclude by saying as a linear stress, or a longitudinal or tensile stress, volume stress or bulk stress, and the third one is shearing stress or tangential stress. So a longitudinal stress, which is otherwise called as linear stress. So it is a longitudinal or tensile stress. It is a stress developed in the body when the applied force produces a change in length of the body. So when you're giving force to a tube, okay, so whenever there is a change in length, we call this stress as linear stress. Okay, so the next type is volume stress, which is otherwise called as bulk stress. So it is a stress developed in the body when the applied force produces a change in what? Volume of the body, right? And the next we call it as shearing stress. So shearing stress is otherwise called as tangential stress. It is a stress developed in the body when the applied force produces a change in shape of the body. Okay, so the first one is linear stress, which causes the change in length. Second one is volume stress, which causes the change in volume. And third one is called as shearing stress, which causes the change in shape of the body. Okay, so the next topic that we're going to see about is about the entrance point. So speaking about the entrance point, the effect of stress is to produce distortion or change in size, volume or shape, right? So these points we call it as entrance points. And the next topic that we're going to discuss is about strain. So what is meant by strain? So strain is nothing but it is a deforming force which is applied on the body, which produces generally changes in the dimensions, and those dimensions, which means the change in dimensions, is called as strain. Okay, so strain is defined as the ratio of change in dimension to the original dimension. So absolutely, when you're giving certain force or deforming force, there will be change in length, volume or shape. As I already told, it is linear stress, volume or shearing stress. So strain is nothing but it deals with the changes in the dimensions when the deforming force is applied into the body. Okay, so strain is given by the formula change in dimension to the original dimension. So strain has no unit and no dimensions. Okay, so speaking about the types of strain here, longitudinal strain, volume strain, shearing strain and lateral strain.